Welcome to our video on Java data types. In this session, we'll explore the fundamental building blocks of Java's data handling. We'll start by examining primitive data types, including their characteristics and uses. Next, we'll look into reference data types and understand how they differ from primitives. We'll also delve into strings, a crucial aspect of data manipulation in Java, and finish with an overview of wrapper classes and auto-boxing, which bridge the gap between primitive types and objects. Whether you're getting started with Java or looking to deepen your understanding, this video will provide a clear and comprehensive look at Java's data types. Let us get started. Let us explore some of Java's key primitive data types interactively. First, we have the byte, which takes up just 1 byte of memory and can store values from -128 to 127. It's often used when you want to save memory and you're certain the nums will be small. For example, think about storing a person's age in years. It fits perfectly within this range. The default value for byte is 0. Next is short, a slightly bigger cousin of byte. It occupies 2 bytes and can store numbers between -32,768 and 32,767. While short gives a wider range, it's still used when memory efficiency is important, such as storing data in large arrays. Again, the default value is 0. Finally, there's int, the most commonly used integer type in Java. It's 4 bytes in size and supports values ranging from -231 to 231 to 1. With this large range, int is great for general-purpose numeric operations where you don't want to worry about exceeding the limit too quickly. Its default value is also 0. Let us dive into the next set of Java's primitive data types. First up is long, which is 8 bytes in size and can handle values from -263 to 263 to 1. It's perfect for large integer values that exceed the range of int. For instance, if you're tracking the total distance traveled in a journey spanning millions of miles, long would be your go-to. Its default value is 0L. Next, we have float, occupying 4 bytes of memory. It supports a range of approximately 1.4 times 10 to the power of -45 to 3.4 times 10 to the power of 38, making it suitable for single precision floating point numbers. If you're working with measurements where some precision is needed, like the height of a person in meters, float is handy. The default value here is 0.0f. Lastly, the double type, which is 8 bytes and offers a range from around 4.9 times 10 to the power of -324 to 1.7 times 10 to the power of 308. It's used for double precision floating point numbers, providing more accuracy than float. This is ideal for precise calculations, such as scientific computations or financial applications. The default value for double is 0.0d. Let's explore the last 2 Java primitive data types. First, we have char, which takes up 2 bytes of memory and can represent any Unicode character in the range of 0 to 65,535. It's used for storing individual characters, such as letters, digits, or symbols. For example, if you're building a text processing application, char helps in handling single characters. Its default value is \U0000, which corresponds to the null character. On the other hand, the Boolean type uses about 1 bit of memory and can hold just 2 possible values, true or false. It's fundamental for making decisions and controlling the flow of programs, such as determining if a condition is met or toggling a feature on or off. The default value for Boolean is false. Both char and Boolean are essential for handling specific data and control structures in your Java programs. In Java, objects are a bit different from primitive types. Objects like string, arrays, and custom classes don't store the actual data directly, instead, they store references to where the data is located in memory. For example, when you create a string, an array, or an instance of a custom class, you're working with references to these objects rather than the objects themselves. The default value for any object reference is null, indicating that the reference doesn't point to any actual object yet. Objects are used for more complex data structure and functionalities. For instance, a string object can hold a sequence of characters, arrays can store multiple values of the same type, and custom classes can define their own properties and methods. This makes objects incredibly versatile for handling complex data and operations in your programs. In Java, type conversion and wrapper classes are key to managing different types of data. Automatic type promotion helps by widening conversions, like when an int is promoted to a long in operations without extra effort from you. For narrowing conversions, such as turning a double into an int, explicit typecasting is required using a cast operator, e.g. int myDouble. Meanwhile, wrapper classes like integer for int and double for double provide object-oriented equivalents to primitives. These classes not only enable primitives to be used in collections but also offer useful methods for converting between types and performing operations. So, whether you're handling different numeric types or working with objects in collections, understanding these conversions and wrappers will make your coding more versatile and powerful. As we conclude our exploration of Java data types, we've delved into the fundamental building blocks of the language. We began by examining primitive data types, understanding their essential characteristics, ranges, and roles in Java programming. We then explored reference data types, which provide the foundation for creating complex objects and data structures. Our discussion on strings highlighted their importance and flexibility in handling text, while the section on wrapper classes and autoboxing illustrated how Java manages conversions between primitive types and their corresponding object presentations. As we wrap up, it's clear that a thorough understanding of these data types is crucial for writing efficient and effective Java code, enabling you to handle data in a variety of ways while leveraging the full power of the language.